So when we talk about the nutrients, the carbon sources, we already see that agricultural residues have been used as a substrate. Then the organic nitrogen will be used. Then amino acids and vitamins have been utilized for as raw materials and as a nutrients in the media formulation. So these carbohydrates are very complex mixture. So we are undergoing the pre-treatment, and for increasing the production also we are using some of the best utilized carbon sources. Then we will move on to the temperature. So for this production by using clostridia, they have undergo some of the optimum conditions like 25 to 40 degrees centigrade. The yield of our solvent will be very good. So if we have been increasing or decreasing the temperature, that will affect our. Then what are the basic requirements? The pH should be 7.5. The total fermentation process will be an anaerobic process. So the byproduct will be CO2 and H. The product will be recovered through a distillation process. The production flow diagram. So once the raw material and media formulation have been identified, then the raw material have been taken into account, and the first step is the pre-treatment. It have been done in this mash preparation tank. So all the raw materials have been crushed, and also it have been converted into some of the fermentable sugars. Then it will undergo some of the sterilization processes. So then it will be fed into our production fermenter. So the clostridium, that is microorganism, have been isolated and it have subcultured, then it have been grown in the seed fermenter until it reaches the log phase. As we all know that the primary metabolites have been produced in the exponential phase, which is nothing but a log phase. Then if it reaches to that, then it will be fed into our production fermentation process. So on applying some of the optimum conditions, either it will undergo best pH of 7.2, the temperature should be 25 to 70 degrees centigrade, and we should wait until we will get a very good quantity of our product. So once the butanol have been produced, then we can see some of the byproducts such as CO2 and H2 will be occur. This will be observed in the and also stored in the absorption tank. Then this product have been isolated or harvested in the downstream processing and collected in the broad storage tank. It have been undergo a further recovery process by using a distillation. So on applying the distillation process, the N-butanol along with acetone ethanol have also been produced. Then this butanol will be taken into account, which is our main desired product, and it will be stored, and it have been packed in the bottles. Then this distillation, after the distillation is over, the waste product have been sent to a filter, and some of the wastewater treatment plant they have sent it off, and the remaining residues will be act as an animal feed. So when we talk about this fermenter, there are batch, fedbatch and continuous process. Here also in this production of butanol, some of the companies are undergoing and they are for increasing the production of their desired product, they have identified which process is very best. We talk about the batch process. The batch is very simple operation, and also it will reduce the risk of contamination, but the productivity is very low because of the either the product itself will inhibit, or else the organism present in that may start utilizing, or the substrate will also inhibit the whole process. So if the batch is nothing but a closed process, already we know that. If we are using this batch, the production of our desired product will be very low, because whatever maybe the medium is present inside it, it's completely utilized by the organism and the product will be produced. But the rate of the product present inside will be low when compared to fed batch or it's a continuous process. So after 72 hours of fermentation, they will check that the product have been produced or not from the fermentable sugar. Then fed batch. So from the name itself we know that the fed batch is that at regular interval we will fed the new medium as well as we will harvest the product. So this fed batch is been can able to avoid the substrate inhibition, and it can increase the biomass. Initially when they underwent this fed batch process, they will use the batch process until the microorganism will start dividing inside it. So the substrate reduction is very good. Then they will undergo the inoculum being fed into the reactor. So this will also reduce the product inhibition because of the harvesting of our product at regular intervals, and the greater cell growth is good in this fed batch because we are supplying the nutrients into it, and the whole productivity is also very good when compared to the batch process. Then we will move on to the continuous culture technique. In continuous culture technique, the medium will be sent, and also the harvesting of our product will also be happening simultaneously. So when it are being reaches to a log phase, when we know that exactly the division of the microorganism is very good, and when it start producing a desired product, butanol, then they will fed the medium through it, and they will start harvesting the product with the same flow rate. So the flow rate sent through the medium as well as the product will be almost similar, so that we can maintain the volume inside the reactor. The volume will be very constant. And by using this continuous culture technique, we can say the productivity is very improved when compared to a batch or fed batch process. So most of the commercialized production, they are undergoing this continuous culture technique. Other reactors rather than the batch fed batch processes and all, they are also using some of the immobilized enzymes, so that we can able to recirculate the cells to achieve a better productivity, and almost 40 to 50% of production have been increased when compared to the normal batch processes. This production reactor the productivity can be increased on recirculating or the cells present in it if we immobilized the cells. And also the cell concentration plays an important role when we talk about the overall productivity of our desired product. And also the membrane recycle have been done. The membranes such as hollow fibers or ultrafiltration have been utilized in order to recirculate the whole cells, that is immobilized cells, and only for improving the productivity they are using this other method. Some of the combinations of normal batch, fed batch, continuous, along with this immobilized reactors or membrane reactors have been used in order to increase the overall productivity of the industries, we can say it. But some of the disadvantages is there when we went for this membrane reactor. One is that if the membrane as well as the microorganism is recirculating and it have been deposited in the membrane, it will cause some of the fouling smell. So that should be overcome by filtering this broth, and on recircling we will go for it, or else the backwash will be given to it. So that's why we are going for a normal reactor and as well as this membrane reactor in a combination also, for increasing the overall productivity. Applications. So this butanol have a variety of applications. So one we say as a solvent, either in paints, coating or varnishes, and also the plasticizer for processing the plastic material. They are using this butanol. It will act as a coating agent for many applications. As a solvent, we can say it, and also in order to obtain some of the chemical intermediates or for the chemical production for plastic processing and all, they are using this butanol as a raw material. And also in textile industry, this butanol will act as a swelling agent in order to coat the fabric. In most of the cosmetic industries, they are using in makeups, nail care products, and also the shaving products and all. This butanol is being used for some of the drugs in antibiotics production and hormone production, and as well as vitamin production and all. As we already know that it is one of the addictive agent along with the gasoline, and also the brake fluid, they are using this butanol, so it will be present in the formulation of component. They are using this butanol as a main source. So these are the overall applications of our butanol. So we can say, if you ask a question about what is a butanol, how we should go for the writing, you should talk about what is butanol, what are the basic uses, and which organism can able to produce it, what is the metabolic pathway of the um, we can the conversion of our product. Then in commercialization, industrial production, what are the agent upstream processing and also the downstream processing of it, and which method is very good for increasing the productivity, and then we will talk about this application. So thank you.